The goal basically is, there are two goals. One of them is learning how to, knowing that there are two at least boards that you can write JavaScript, and it sits on the board themselves, and instead of writing C code and programming with the Arduino IDE or whatever, you can write JavaScript and control different pins. And another takeaway from this section is also learning how to combine the boards that you guys are building and do what Tomer did 2 weeks ago, something like that, when he created a Node.js server that speaks serial to your board, and then speaks with the Node.js also speaks with an open socket, hey, to some application, web application, and then close the loop and have this web Node.js AVR communication. Does that make sense? You want to give a short?
Yeah, I'll just give an intro because he did all the work this week. No, he did. Well, so I like to stand up a little bit, but yeah. So what you have to, I just wanted to give a little bit of background. So what are your backgrounds? So obviously you know about this stuff, but what about you guys? What are your backgrounds roughly? Just like architect or architect two? Yeah, I recognize you guys three.
But I know some JavaScript stuff.
Okay, good.
I know a little bit of JavaScript.
Great.
I'm a physicist, but no, nothing.
Okay, so you're a physicist. Yeah. Nothing applied, right? What about you?
I write a lot of JavaScript web applications.
Okay, great. So you'll like this. And
in aerospace, I've only just learned Java.
oh, Java?
Yeah.
Not JavaScript?
Yeah.
Okay. You'll like JavaScript. Well, I don't know how much of a hardcore Java person you are. You might hate or love JavaScript. Yeah. So effectively, here, let me just get a browser. I just want to put a couple of things.
Are you one of the TAs or?
Me? Yeah. I TA'd the class last year, this year, and I've TA'd very little this year because, I want to get stuff done. But okay, so there's a number of things. So when you use Arduino, right? When you use Arduino, and I'm just going to put this so your brain associates things, but when you use Arduino, you'll see that you still have to write C code. Now Arduino C is still kind of an abstracted version of Arduino, so you'll have all sorts of things like serial communications that are just basically one line, like serial dot open or serial dot print line, and that actually translates into a number of subroutines or functions that get used. If you've looked at Neil's code in the past few weeks, you'll see that he does all sorts of fancy stuff at the top of his code, and actually that is re-implementing a lot of the serial communication from scratch. There are two main reasons why you may want to do that. Purity, which is not the best reason, but also size of code. That is actually a very good reason for doing this. The Arduino environment is a little bit bulky, a bit in terms of memory. So if you're trying to embed these things on small memories, you'll be limited by some of the Arduino applications. Now, you could also just use a microcontroller that has more memory. Right? Right now this is becoming less and less of a problem. And actually, as a matter of fact, what you'll see today is mainly a result of these CPUs or these integrated units becoming so popular and so easy to get that you have things like the Raspberry Pi running an entire Linux OS on basically a credit card sized computer. That is a fairly recent development in terms of electronics. So you have Arduino. This would be kind of if you didn't know really C and you wanted to get started, that's where you get started. And they have to be credited for being the kind of the first cheap and cheerful microcontroller. And they've evolved a lot in the past few years with
like AVRs not exist in the hobby space before Arduino?
Not really. I mean, people may say that. Well, before that there was stuff like the Parallax. There were a lot of other products, but they were mostly built for EE people. And actually, when you spoke to, and this is true today still, if you speak to an EE person, they're like, that's easy, Arduino is bullshit. Well, you open a lot of products, and these things get started off of Arduino. So it's a different value. It's maybe for the hardcore EE person. Now, if I'm correct, nobody's a hardcore EE person around here, or so you know, it serves different purposes, different populations. However, C is still a bit painful, and libraries are not always easy to deal with. I personally don't like C so much. And so what you can do, there are other things that have cropped up literally in the recent years. So there's one that actually runs Python, MicroPython. We're not going to talk about it in detail today, but I just wanted to put it on your radar. This was off of Kickstarter last year, and they're now selling them off of the UK. They're really, really cool little boards. Again, the same principle. What's happening is you take a unit and you're running an interpreter on top of that unit. And that's what most of these companies or people or environments, that's what they do. They create that translator. And so then you can just drop in JavaScript code or Python code into this, and it runs the hardware, right? So the painful part of translating to the hardware, which is what abstracting is basically what Arduino does to a lesser extent than what Tessel and the Esperino do very well.
Can I ask a question about the hardcore EE people? Like, have microcontrollers kind of eliminated a lot of the circuit design that people would have to do when they implemented circuits to do stuff that microcontrollers do with all like lower level parts? Or is that
yeah, I mean, in general, that's a trend. Okay, again, disclaimer, I'm a biologist, so, you know, like, not really a microcontroller person. I've been doing a lot of electronics in the past 2 years, ever since I took the class, really. And actually, I would say most of my research time now is bridging electronics and biology in weird ways. So, well, I'm at the media lab, right? So yeah, so it is a trend that people are going towards ICs a lot more just because they're simpler. Like, for example, yes, you could use a thermistor to measure whatever you want, you know, temperature in this case. But you could also just use a I2C temperature sensor, which is much more sensitive, has humidity, is calibrated, and you don't have to deal with all the calibration code, and you just have to talk to it via I2C. So
Think
it's
about
a lot
it like a
easier
library.
to.
If
Right.
you're
It's a
from
hardware
the-
library.
Yeah, it's a hardware.
That's a good way to put it. Yeah. It's kind of like a hardware library. So you can abstract and you can start building things from block diagrams a lot more than you would otherwise. However, analog circuitry still has a lot of uses, right? Notably in like RF and audio amplifiers, all that stuff. Like, there's a lot of analog, and I'm not saying that it's not valuable, but clearly there's a trend towards abstracting up because it makes designs easier. And this is kind of the same idea. This is abstracting up, but on the language side, and not so much on the well, I mean, they're doing the hardware for you. And so you can abstract, and you can now have a single code base with at least the same language. So if we look at then running JavaScript type language, so JavaScript, sorry, that's not what I wanted to do right now. Just Google JavaScript. So the Esperino is this little green guy, which my opinion of it is actually pretty high. I personally like it a lot. It's an ARM core running just a JavaScript interpreter and JavaScript engine. And what's nice about it is it has a bunch of prototyping space, as you can see, and it's clearly built for people who are going to hack around with, again, what you were saying, which is the hierarchical modules. So if you look at the back, this little socket here, let's see if I have a picture. Surely if I do this, it'll show me something, right? It'll show me what I'm buying. Okay, yeah, this is
Try
not.
command minus and maybe the entire picture.
Yeah, so this is surface mount prototyping space, and you've got kind of perf board through hole prototyping space here.
What's
Couple
service
buttons.
mount? Is that like a breadboard for service mount?
Yeah, that's basically it. So if you were, for example, if you wanted to, let's say power something bigger, and you wanted to make a voltage regulator in there, you could solder it there, and then you would touch all 3 pins right on all.
So instead of using a breadboard or like an external pad, you just
instead of designing something in Eagle, milling it, and doing that, you could just put a couple components here, try it out, desolder it, and once you get it right, you make a board. It also has an SD card. I wanted to show you the other side.
just Google Images.
Yeah, maybe Google
why do you randomize the? I hate this. Okay, so here, this is an example of somebody actually prototyping with a surface mount part, and then running wires all over the place to get their prototype running. It's dirty, but you know, if you guys are at MIT and you don't know what hack means, look it up. But it's very useful, and at the end of the day, that's how you get stuff done. What I wanted to show you was this little socket, just an example that they know they're targeting this device for people who actually are going to play around with the Bluetooth module that we have in stock for this week. This is actually the pins for the Bluetooth module already like pinned out to a whole bunch of stuff. So you could basically just take an HC05 from the stock, solder it on here, add a couple of jump leads, and then you would actually be sending via Bluetooth and writing your code in JavaScript, which is kind of cool.
Why do you like it better than the Tesla?
I do.
Why?
Tesla is a bit okay. So I'll get into it in a second. But Tesla is a lot more involved. It's I think potentially more powerful. This is more limited, and it does what it's doing something a lot less ambitious. But it as a result, it's a lot tighter. Now Tesla, I think, will be awesome like 6 months, a year from now. Full disclaimer, I know those guys really, really well, the Tesla guys, so I'm a little biased. I really like them. I think they're doing awesome work.
But you just said this.
But
is
oh, you
you're
said
a
that
crappy
you prefer
friend.
Espirito.
I said that I prefer the Esperino for very basic things. I also said it's less ambitious, right? So I didn't necessarily just say positive things. It just depends what you're looking for. So the Esperino will run JavaScript, which if you're just looking to do basic JavaScript on there, it's fine. However, most of the time, especially people who do modern web development, are not using just pure JavaScript anymore, right? I mean, we're using all sorts of libraries. A lot of us are using Node.js as a backend language or framework on top of JavaScript. And if you're looking to do something a little bit more advanced, then the Tesla is more in your target range. The other thing is that the Tesla has a lot of engineering in these ports, the ports here. I disagree with the way they're stacked, but anyway. So you have the ability to literally just buy these little modules and get started, and just plug these things in. So they have audio, BLE, ambient sound, accelerometer. They have a GSM, GPRS. They have a micro SD, infrared, servo, RFID. They have a relay. They have these NRF24 modules, and literally this is just plug in, import a library, and it will just work, right? So if you follow their tutorial, it's going to be very, very simple. But it's very powerful in the underlying infrastructure. As a result, it's a little bit heavier. So when you upload code to it, it will take a little bit longer. The firmware is a little bit chunkier, but in time, it'll be like really kick-ass.
They also have a restriction about different libraries that it's
Yeah, so this is why I said that they're trying to do something very, and again, full disclosure, right? I tell these guys a lot. They're trying to do something really ambitious. They're like, I believe, last time I saw them before they moved, no, they hadn't moved already. There's a team of 6. They're all kick-ass engineers out of Olin College out here. They're really, really good people, but this is a big project, right? So they're supporting God knows how many modules down here, and they released a while back. The boards have been out for a little while. They've ironed out some of the kinks, and they're still ironing out some of the kinks. So as a result, some of the libraries that you may be using as a Node.js pure software project on your computer may not work right out of the box. But post on the forums, they're extremely responsive, like really extremely responsive. And that's enough rambling for me, I think, because we should look at some code and some examples that he's worked on. But any questions, maybe more on the architecture or project ideas, or you're not sure how to implement certain things?
You want to say maybe one word about how they made it possible to run JavaScript, both Spring and
Yeah, so effectively what's happening is that you have a stack. So if you think about hierarchy layers, right? So the reason this is there, Lua, basically they're building a Lua interpreter on top of the silicon effectively. So what you need to translate JavaScript code to machine code, then that to think of microcontroller instructions. And that's the hard work that they've done. And that's why some of the Node.js libraries will not be compatible on the Tesla yet, because you can't support all the libraries that are out there for Node.js right from the get-go when you're a team of 6.
So Espino is running an interpreter, but Tesla is not running an interpreter?
They're both running an interpreter. So you have to, when I was saying you're interpreting JavaScript, that's your layer there. And then there's a second layer of interpreter for the Tesla. At least I remember their stack is pretty thick. I don't remember all the steps, but there's a Lua interpreter as well. And you can go through the stack. I mean, you don't necessarily need to understand that fully. You just have to understand that there's different layers of hierarchy, and that there's a reason why this hasn't existed before. Is that nobody's really done all the hard work of moving all this JavaScript code down to the silicon. It's a lot of work, which is why I say this is ambitious, and they're pulling it off, but give them a couple more. And the docs are very good. The projects are very good. Examples are very good on the Tesla. A little bit less well documented on the Espruino, and even less on the MicroPython. Arduino is obviously very well documented, but that's just through sheer time. Okay.
Cool, let's dive in.
Right in.
Awesome. Thanks. So I'll give you a link. You can see that almost everyone are holding a computer. It will be easier for you to just go right in. So let's see. Let's start with serial to web. So go to github.com. You see the address, right? Emil Zlovich/serial to web. So all the code will be available to you. I'll send you a link, don't worry about it. We'll see how much time we have, but we'll start with the boards that you have, something that is similar to what Tomer has done. You can look at Tomer's example, he's actually pretty awesome, so just go to Tomer's site and see what he does. But here it's something a little bit different that works with my board, and it does also two-way communication, which I think you already implemented. So everything you see here also you can go to Tomer and see as well. Let's see how the code looks like. So, and by the way here, so I gave you also the design. If someone wants to create like a remote control, something like that for his project, then you can just download that or customize that and do whatever you want with it. So you have the design and you have the Arduino. I'm using the Arduino IDE in order to program the code inside the board. It's just easier. Let's see how it looks like. How many of you know a little bit Node.js? Just raise your hand. So I'm not going to go exactly why I'm writing here, require, and what exactly is blob or serial port or whatever. I'll highlight the important stuff, more or less, and then you can go to nodejs.org and go through a really, really quick and easy tutorial how to use Node.js and how to connect your, to communicate with your board through serial. You can download my code and change it a little bit, and download Tomer's code and change it a little bit and tweak it for your port for whatever you want to do. So you can start with that if you don't have any experience and you don't want to start messing and getting really dirty and understanding a new language or a new library.
Perhaps we should just say Node.js as it relates to JavaScript. Node.js is a little bit different in the way you write it because it's asynchronous language. So it's meant to not be blocking. So if normal, in most languages, what you do is you're going line by line, and if you're doing, say hello and then say world, your program will normally execute say hello and then world. In Node.js, that may not actually be the case, just so you know. And so it's a little bit, it's a different way of, right? It's a bit different in your brain how you structure that. You have what are called callbacks. So if you write things just one after the other, you may not, if things start executing out of order, that's the reason why. And so that's why the way you most of the time write Node.js code is by abstracting, again, many of the functions. And those, when he does require at the top, those are just, think of them as software libraries.
So, a couple of interesting imports here, libraries. One of them is serial port. You know what, let's start with an example to just show you what this thing does. And then I'll just dive in and connect the dots. Let's hope that it works. Let's see. If I press on this, then it sends some events to the web, right? And if I
Here, can you show me your computer? Which, so just,
yeah.
So this is not just, so he's actually connecting to the web address, but I could actually connect to his computer and I could show you that I could see
1885.26, and you guys can connect as well. 1885.26.94, just not all the same time. And port 8000.
8,000. Yeah, so here,
It's going to show
yeah,
on both
it's going to
computers.
show on my computer as well. So I can see backward, what he's pressing. So you now have an ability to
People are sending us stuff, right?
leverage the.
Yeah.
So yeah, so if you press those buttons, they will flash. So anybody who's in their computer and will do that, then it'll flash up for it. And the way it's working is that you're bridging the internet to something local via a serial port. Sorry.
Here, somebody's pressing stuff. Cool. So it works.
No.
Let's
Better
see.
hack into his machine while I still.
Yeah,
This
please.
is a very nice injection.
Oh,
That could.
Don't try to do something. Oh, yeah, try. So one interesting library is, sorry, it's off. Listen. So one interesting library is a serial port, and serial port is the library that enables communication between the serial and the computer. Let's see what exactly is happening here. And like the code is pretty straightforward. All you need to, like, don't go and read this. This is more like configuration code and things that repeat themselves. But the main here is what runs the first time, and I'm calling it right here, all the way to the bottom. And this is setting up arguments, so you can pass arguments. This script, not interesting. Making sure that the serial connection is alive, not interesting. Printing the settings is not interesting. Setting up the serial. So this is kind of interesting. Let's see what's going on here. So this uses the library serial port creating a new serial port, giving it a port, baud rate, and some kind of parser. You can use whatever parser you like. It's more like it's every message that it gets, it separates the messages by a new line, like /r/n. That's what I get. But you can use the default one, and it will work, and you can create your own parser or whatever.
That has to go hand in hand with what runs on the code on the
Right.
firmware on your board, because whatever will come through will get interpreted. The parser is just this way of chunking, of cutting whatever messages that come in an easy way. Otherwise, what you would have to do is, which is what many of you might be doing with a serial port, is you're looking for a specific character, and once you look for a specific character, you know, oh, whatever's after that is my message, or whatever was before that was my message, right? So you have this kind of like, it's called a delimiter, right? So in this case, he's using a new line, and the serial port function has a subroutine or sort of a function parsers that will do that for you. You just need to tell it what character you want. So
Yeah, perfect.
just abstracting that
I'll
out.
just relate to Neil's examples. So this example is really good if you're writing logs to the serial, so that after each line you get an event with the line that comes from the AVR. But if you're using Neil's example for temperature reading or anything, there's never a new line. Character just bytes keep coming in. So what I like to use is just like a single byte parser. It's called a byte length parser, and I initialize it with 1 as an argument, and this way I get, after each byte, a callback. Now, another reason why I like the one byte parser is that I can just send whatever I get to the client side, and the client side will handle actually understanding what needs to happen. So
Like a complete proxy without any logic.
yeah. So
anywhere else.
this is like a matter of ideology, but I think it's better to have like a very thin server and do like most of the processing on the client side.
Yeah, it makes perfect sense actually. So this is opening up the serial. Once the serial is open, we get inside this callback here, and then we're listening to data when it comes, every time the board tries to print something to the serial, and we'll see in a second how it does that. It will reach here, and then I'm printing it to the console so I can see it, and also proxying it to through a WebSocket to any web client that listens, and we'll see exactly how I create that web client and how I close the loop from there. But let's see. Maybe it would be a good time to open.
Do you guys have any questions so far?
Yeah,
Feel free to
stop
interrupt.
me, please.
Lost, completely lost. No,
So-
following.
Let's close the loop, and this is probably code that you're familiar with. This is just boilerplate. I'm turning on the light, and I'm turning it off after a couple of seconds or milliseconds. But here's me handling the buttons and then reading from serial. So let's look at the buttons code. Handle button. So it will call on button pressed. Every time the button is pressed, I'll get inside this function, and then everything I'm doing is just print line. So at the end, we'll print also the line character, the end line character, and then also some message, and then it goes back. Yeah. Did I confuse you? What else is interesting? Okay, so now what is this IO emit thing? Let's see. So here I'm setting up the serial, setting up the web. Let's skip this for a second, and also I'm setting up the socket. So socket, what I'm doing is every time I get a connection, I create a listener. So now if the web client, every time the web client connects to my server, this callback will be called, and now this socket represents the connection. It's actually a connection, it's not really a socket. It's a connection between the server and the client that just logs in. So
think of it as kind of like a web version of the serial port. It's like it's actually there are many ways of doing connections on the internet. This is actually a fairly direct one. So you're opening a socket, which is a Linux term, between two machines. Let's say this one and that one. And so you have to understand it's direct. It's not you're going through some broker or anything. I mean, your data may be going through some routers, but you're going directly from that machine to another machine. You're not both connecting to a server. You're connecting directly one to one.
And it's quite fast as well, because the connection is always open and you don't have to reopen the connection every time like you do in any HTTP, for example, request. So now, I'm saying that every time I get from this socket, from any connection, like you guys connected to my computer, if I get an event with this key LED, then this function will be called and I will do something. And here what I'm doing is I'm closing the loop, I'm writing to serial. So the board would be able to listen to what the web is sending it. Like when you guys clicked on the LED 1 or LED 2, it reached into this callback, and then it wrote what you sent to the serial. And you could probably crash my code if you change the value of what you guys sending. And that's what he probably tried to do before I started.
What happens if you crash, like if you make the microcontroller have some invalid value, can the program get into like a weird state that it's not running the loop anymore?
Yeah.
Or, I guess there's no like,
You have all the
segmentation
power.
fault, but you can make it do weird stuff.
Yep.
Right?
Yep. And as a matter of fact, if you look through the code, there's a nice way to inject code into his machine, or at the very least probe it in inappropriate.
Like this, for example.
Well, don't point it out. So spawn just opens a process, so you could actually just open processes on his computer. Anyway.
Or on your computer when you run.
Why do you spawn new processes?
Because every time I
Yeah.
open the, like here,
Like that's not gonna let you open process on his computer though. You have to be able to send that over.
like if I do this, node app, then instead of opening the web browser, it will just open the browser from.
Yeah, he doesn't do any checking on a whole bunch of arguments.
I'm pretty lazy.
I mean, it makes sense. You're not. It doesn't matter, right? I mean, obviously, if you were to use this in production.
Yeah.
Well, he has to run that on his computer, so I mean, I can't spawn a process on his computer using that code. I can spawn a process on my
There are
computer.
ways to do it. Anyway, look it up. You can do it.
Write to serial, and here what I'm doing is I'm just writing to serial and I'm appending a new line because that's my protocol. I like to be consistent, but again, he's also right. If you do byte by byte and then do the logic in one place, then it's so let's see how I'm reading this data that I'm writing to serial. Read serial in loop, and it calls eventually on read serial.
We're now on the microcontroller.
Yeah, on read serial, and on read serial, what it does is it gets. Well, you can see exactly how I'm parsing it because I'm waiting for a new line until I call this callback on read serial. I'm going byte after byte, and until I see this special character new line, and then I'm considering this like a chunk, and then I'm calling this function. You can scroll down and look at the code of exactly how I'm doing that. But when I get this chunk, when I get the entire data until I see the new line, I call this function, and then I get in. For my case, I'm just changing it. I'm assuming that the value that I'm sending, this is the protocol that I created, so I know exactly what's going on. So I assume that it's an integer, so I change from ASCII to integer, and then I get a value, and then I'm doing a really type safe check to see if it's either 2 pins, if it's something, if it's 2 pins, if it's those, if it's one of those pins, then I'm just writing the value and turning the LED on until a certain time, and then I'm looping that, and then I'm echoing back the value that I got, and I'm not using here print line because N already has a print line, a line end line character inside of it, so it's till now, all more or less good. You'll have the code. It's not meant to be explaining the entire code and the entire libraries and exactly how to use it. More like going through the code, so when you go over it yourself, you'll be more comfortable with it. That's more or less the idea here. But if you have something that is like really weird and you don't understand what's going on, stop, please. So that's more or less closing the loop between the reading and writing to serial, both on the Node.js and on the board itself. And one last thing that you didn't see here is how I'm creating this WebSocket, web server. So setup web, and that's just a boilerplate for how you create a web server in 2-3 lines of code. So nothing special. But this is serving static files from 2 different directories. So you can use just one directory, whatever you want. And now let's see the code, the HTML code. So that was the Node.js, and then we saw also the Arduino code, the board. This is the HTML website that you saw before. And it's not doing anything fancy. The only fancy thing it does is this. It creates a new socket from a library called socket.io. It wraps around something called WebSockets that creates this easy and one-to-one or, well, fast communication channel between your server and your website. And then I'm just listening. And then I'm listening to an event called data, and every time I get that event, you remember before we saw emit, io.emit, every time I get something from the board, I emit it with this. Let's not just point. Let's show. Every time I get a serial event from the board to the Node.js, I emit the data that I get using a key called data. And then on the website, I listen to this event, and then I just print this message. Well, I just change a label inside the web
So
with this data.
the reason you need to do this, by the way, because if you've been following, you have a board that's connected by a USB serial port to your computer. On your computer, you're running a web server, right? That connection is the serial port that we saw earlier using the Node library. Now, if that was all we had, there's no way for a client, i.e. me or you guys, connecting to a server to actually send the data over. So we need, that in web development is called the difference between the server side and the client side, right? So what you're looking at here is the socket is actually tying the server side, which is whatever's running it. You could put this on Amazon, you could put this, well, I mean, you need the serial port on Amazon, but you could put this machine anywhere, and you could connect to it from anywhere around the world, providing you have a public IP. But you need to tie the client side to the server side. Otherwise, your messages won't go to the computer that has the serial port. Right? Just to be clear.
And then every time you click on a button, I'm doing the same thing, but just on the opposite side. I'm emitting an event with this key and the value from here. And that's actually the pin number. And if you remember seeing this word LED, I'm listening to events. You remember every time a new connection is established, I'm listening to an event with this key LED, and then I'm writing it back to the serial. Closing loop. That's it. That's how you close the loop between your board and your computer.
And the web.
Any questions before we go into this embedded JavaScript? Cool. Cool. So let's start with testing.
Yeah, I don't know.
Yeah. Let's see. Okay. Let's play with testing.
So, okay, so now the server, while he's setting up, the server was running on the computer, right? But what if you could get that exact same code, which was Node.js code, to to run on a microcontroller, right? That was kind of that is the purpose of the section of running embedded code. But now you could actually use the exact same code. Well, you could use the code that was running on his computer and actually push it to the Tesla itself. So now with a battery, this guy could connect to any Wi-Fi, and now your server is this big instead of being that his computer.
Keep on talking when you're
Okay,
Wi-Fi.
so I'll fill time. Now
Yeah,
you could also what you can also do is then use some Tesla pins to put a serial port between your Tesla and whatever board you made. So you could make a little Tesla shield that would fit on top of the Tesla, and then you would put a battery, and there you go. You'd have your web server right there. You could just hide that in a corner, and MIT would be looking for you or something.
Yeah, very cool. And you know what's more cool than that is that you get Teslas. We have 2 Teslas here for you to play with, and if you guys want more, we'll buy more. And we have 4 Espruino, maybe 5, that you can also play with. And again, if you want more, we can give you more. Just tell us and we'll order it. So what I did right now, while he was speaking, I connected the Tesla. It has a Wi-Fi chip inside of it, so I connected to the MIT Wi-Fi network, and now it has an IP. Let's start with an example. Tesla run app.js. So I'm now deploying a different code, quite similar actually, onto the Tesla. And now you can log into it. 18.1.11, 24.166, port 8,000.
Yep. So actually, I can see here. This is actually running on the Tesla, right?
I can connect it as well.
Yeah. And so
Here,
if
a
I
lot of
press
people-
the lead button,
you press it.
you can see every time I press the button or somebody presses the button, one of the events on the port will turn on. This is the reason this is showing up on his computer is because there's a debug kind of line running from the Tesla to the terminal, and so he's just outputting so you can see the
Yeah,
details.
whatever you're saying.
So
No. No. It's good now. Cool.
yeah.
No, there's no button here that I can show you that you can
Yeah.
also communicate back, but it's pretty possible. It's pretty
We
straightforward.
could
But,
short
yeah.
2 pins if you wanted.
Let's see the code. Test. So if you go back, if you want to see the code yourself, so instead of serial to web, just write Tesla. Tesla to web, and you'll have your code. And the code is even simpler. Because unfortunately Express, the web server that we used before, can't really run yet.
So there are many ways to run a web server. Think of them as just more or less frills. And some of these environments, like Express, are actually pretty heavy. We use them, for example, in a couple of production environments on our end. We use Express. That doesn't yet run on Tesla. It will at some point. Actually, it's one of their priorities, so it will. But that's one of the examples of just a lot of code needing to work all the way down to the silicon, and so that's pretty tough for them to do. So instead of doing that, you need to use a separate framework. They like to call them frameworks for running the web server, and it may have fewer functions, but this one in particular, Tiny Router, runs on the Tesla.
And also Socket.io, the same library that wrapped something called WebSockets, also doesn't run yet. So we're using just WebSockets, which is the same thing, just less ease of use maybe, something like that. But you'll see that it's pretty straightforward. And this is just using the file system, and that's the Tesla library. So again, we have this main setup web. and this is equivalent to the other web that we set before, just a little bit different syntax. Setup socket. Here we create this is before when we created a socket was like 2 lines of code. This is more or less the same thing. So we're creating a server, and it's actually creating a socket. So every connection we're getting will step inside this callback function, and then we're saying that every time we're getting an event from this connection with this keyword, then we'll step inside this callback. And then we're doing something. And what that something is just, using the Tesla library to command the board to do something, which is kind of cool. So here we're just switching LEDs, and toggling LEDs on and off. Depends on what we're getting. And then we're closing the loop, sending back the acknowledgement to the web, so you can see how this communication is happening, and the web can see something that you guys know that actually your command was sent and everything was fine, and then you can do whatever you want with it. And that's it. That's the code for this, and I'll show you, and please again stop me if you have any questions, but it's pretty straightforward and you can quite understand it. And here it looks, again, more or less the same. Instead of using a library that wraps this WebSocket API, you're creating it from scratch. So new WebSocket, that's your socket. This is your the AP, the port that you're listening to. Every time you get a message, you're doing something, and also you're sending every time you're clicking on a button. You're sending some values. That was it. Pretty easy, right? Pretty cool.
So again, we just wanted to take an overview of what the code looks like, stepping you through it, because if you haven't looked at it at all, it might be a little daunting. But really, it's actually made to be abstracted as much as you can. So all the functions for the Tessel are actually embedded in this node library. So you can just do, as you saw earlier, you can do like tessel.led.toggle, and it'll toggle the LED. So now the real advantage of this is that now you have this kind of one set of tools that also control hardware. And it's web embedded. So as I said, put a battery on this thing, it already has a Wi-Fi chip. You could toss this around, you could put this in your bag, it would connect to MIT Wi-Fi all the time. So you could have this kind of little on the go. Like let's say you wanted to make a robot that moved around. You could have the little Tessel that connected just a couple of servo boards. It would move it, and then you could actually toggle it from your cell phone by just opening the IP address of your server, right? Which is actually really cool, a lot easier. You don't have to deal with Bluetooth. You don't have to deal with routing the information through a series of pipes. It's just like,
So
it's a lot easier. Also, the nice thing about MIT is that when you get an IP from almost every part of MIT, they're public IPs, which
I think it's only the Media Lab, not the Ethernet.
I think it's the Ethernet, the Media Lab is not public, I think, because it's routed through 18.85 is Media Lab. So depending on the subnet, but the class that we have. But MIT has all of 18. So 18 dot is MIT, and so 18.111.24.126 I think was that particular Tessel. You could have all of these connect, and you could connect from, I was going to say Iran, but like maybe that's not the best place to connect from, but whatever.
Yeah, and it's actually like once you open up a web server on and connected here, you just get start.
Yep, you start getting traffic, which is
like hacker traffic.
Yeah.
IP port scans.
Yep.
which is kind of cool. So last but not least is this weird looking Esperino, and the code here is a little bit different. Like I see that you guys are hacking
It's
stuff.
not me.
Who's hacking? Nobody's saying.
Not me. Stop hacking.
It's him.
There's only one person typing, so.
Sorry. So actually, all the commands that you were sending were running on this. So if I send this command, led1.write1, yeah, it worked.
Why does that board run Express with the Tessel doesn't?
This does not run Express.
So what's this code on your GitHub that you're starting an Express
It's,
server?
oh,
But
This is
did
on the
you notice
computer.
that
Oh, I see.
before, when we
I got it.
ran stuff on the Tesla, we said Tesla run and then the code. So we uploaded the code to Tesla, but now we're running locally.
But the Esprino is a library for Node that talks to an Esprino from.
Esprino does not do Node.
There's a library, I think he's
There
looking
is
at
a
the
library?
library called
Oh,
Node
right.
Esprino, but it's just a wrapper.
Actually, it's a
for-
really shitty. It
Yeah.
doesn't have anything in it.
Yeah,
doesn't have any
Esprino's
needs.
running JavaScript and Node Esprino lets Node talk to an Esprino. That's
That's right.
Yeah.
Yeah. So from your computer. So what we were doing a second ago, just to clarify, the Tesla was hosting the code. So again, if I had a little battery pack and we were just running the Tesla of the thing, it would be alone. The Esprino doesn't have Wi-Fi connectivity of its own, so it can't do that. But you can add it.
That's
can add
what's cool about it, and it's way cheaper than Tesla.
That's
So,
right.
but it also runs code inside. So, and for example, let's see its code. Spring or something.
Yeah.
So there's an IDE for it, and it's pretty cool. Like it's an interpreter. You write and immediately it evaluates your code. And this, if you guys see it, yeah. So this sits on the board itself. There's a function called LED, and it gets a variable called state.
Why don't you actually just evaluate it just to show?
Yeah, it's here.
I was
Call-
saying on the IDE
Oh,
itself.
you want to show it there?
Yeah, just to say that you don't have to run a server. You can
Oh.
actually just run it in the console. And so you could just do LED.
One. Oh. There's this. False connection. Maybe it's because of the button. Is it on?
Yeah, it's on. So
So now
turned off. You turn it back on. So again, you can. The nice thing about it is you can test your commands on the left hand side. Then you write it on the right hand side. Then you can upload it.
It's really easy. Fast.
It's super
so
easy,
fast.
super fast. Now, obviously, the test. That's what I meant earlier. Is the Tesla's a little bit heavier, but it does a lot more. But if you would just want to hack around and get something to work, this might be a bit better. Now, if you want, you want something that's connected to Wi-Fi, the Tesla's easier because all the library's already built in. There's one command, and you just connect to the Wi-Fi, and it's done. Right? Whereas here, you would have to figure out the power, put the little Wi-Fi adapter that we have on the library today, this week, on the class site this week, the ESP8266, and there's a couple of idiosyncrasies with that particular chip. So it really depends what you're looking to do. Sorry.
Yeah, that's perfect. So, and like just to close the loop, you see that there's a function, and you can call from the web, which is kind of cool. And let's see if it works. Yeah, cool. It works. Call it this. And this is pretty cool, and you're getting like the return value. It's pretty dangerous, yeah, as you said. It's pretty dangerous, but it's good for prototyping and fast creating something. And it's kind of cool, right? You're writing JavaScript, you're sending commands, and it runs on an STM32.
It's
And you can control
super
things.
cool, right? I mean, it's super easy. If you even just last year when we were teaching the class, STM32, just these things just did not exist, and so the tool chain was a pain. But I remember I taught an entire hour-and-a-half class on how to set up the tools, and it was just like, this is not going to work. And you wait a year, and now you got this stuff where you just click connect, upload LED1, right, and you're set, right? So we're a lot farther. I wanted to say one thing. Can you show the web ID? Yeah. One thing that is good to note here is that if you write the code here on the right hand side and you click the upload button, that will upload the code up here, but it won't actually commit it to memory. So if I were to remove power, or your thing loses power or whatever, it won't have any code on the microcontroller itself, which most of the time what you do with Arduino is you upload it and you kind of assume that it's going to stick there, and the moment you power it back on, it's going to start its loop again. This is not going to happen here. What you need to do is you write it up, you upload it, and then you type a command in here called save. Just save, and then you need to import, yeah. And so once it's you do save, yeah, so you would do save, there you go, like that, and what it does is it erases flash and then uploads the code and actually commits the code to memory. So, there you go. And so now the code will run, and so the nice thing about the Esperino is, again, it has even a JST battery connector. So you just get a LiPo battery from SparkFun or anywhere, and you can literally just connect it. You don't need to do anything. And I believe it has an embedded charger, so if you then connect this to a micro USB cable, it'll charge your LiPo battery. So it's really kind of this little thing. Now, like, for example, the Tesla doesn't have a LiPo charger or a LiPo circuit. Well, I mean, really only one IC, it's not that difficult. But it doesn't have that. So there's slightly different offerings in that regard. But if you're looking for something very simple, where you don't necessarily want to do a lot of work, and you just want to run JavaScript on a microcontroller because that's cool, and then Esperino is the better choice. And if you want something that's web enabled and you'll put a little bit more effort in battery management and stuff like that, then Tesla is definitely your better bet.
Cool. You guys tired? Was that fun? Yeah. Cool. Any questions? Good luck. I'll be your TA this week, next week.
Do you guys have questions about projects specifically that you want to shoot off, like ideas that you may have that you're not clear how to approach, or?
Oh, sorry. One last thing is just if you replace the Tesla with Esperino, you'll get the code first.
Or you could just follow this guy on GitHub and then you'll get all the updates. Which is what I just did like 5 minutes ago.
Yeah, sorry. You were asking?
No, so if you guys have any questions about, or if you have ideas about the projects you want to make and you're not sure what to use or why, or just feel free to reach out.